So we're going to talk about the slope of a line. So when I have a function or equation where I graph it, I graph all the infinite number of points on this line, I get this line. That would be something that looked either like this, by equals c, standard form, or y equals mx plus b, which is slope-intercept form, or y minus y1 equals m times the quantity x minus x1, which is point slope form. Or if I just had a jumble and I had an x and a y, it would be a linear equation in two variables. When I plot the x versus the y in the form of coordinate pairs, I get this line. And lines can come in different steepnesses, if I can say that word, use that word. And so, for instance, this line is more steep, not a very mathematical term, more steep than the other one here, this one. So we'll call this line 1 and we'll call this line 2. Line 2 is more steep than line 1. But that's not very mathematical. So what we do to describe the steepness of a line is this idea of slope, which, as you can see above, we typically equate it to the variable m, and we calculate it by taking the change in y and dividing by the change in x. So in other words, it's the change, that's the Greek symbol delta, which represents change, the change in the vertical from one point to another, divided by the change in the horizontal from one point to another. So we can take a look at that in more detail, just to drive the point home. And so now I have another coordinate system, and let's see if I can grab that. No, I can't. So we're going to put some points out here. Let's put this point, which looks like negative 6, 3. And let's put this point down here. And this would be what, 7, negative 2. Okay, so I have these 2 points. So we should recall from geometry that to define a specific line, I need 2 points. So that means from that information, the 2 points, I can get the equation that represents all the points that are on that line that contain those 2. And there is no other line that will contain those 2 points. It's unique. So the 2 points, I can calculate the slope, which this video is about, by taking the change in y and divided by the change in x. Or change is often calculated by taking a difference. So I'm going to take some y value and I'm going to subtract the other y value. Now here's where, and then divide it by x minus another x value. So this is where we start making some differentiation here. Which y value? So if I choose this to be my y2, then I'm going to take y2 and I'm going to subtract y1. And that's going to be so this is going to be 0.2, and this will be 0.1. And we have to be consistent in that, or our calculations are going to be wrong. So I'm going to have y2 minus y1, and then I must take I must take x2 minus x1. And so this is my x2 because it goes with the y2, and this is x1. And so my calculation becomes negative 2 minus 3 divided by 7 minus negative 6. And so the slope of that line, it's going to turn out to be negative, is negative 5 divided by 13. So I have a slope m of negative 5/13. That's the idea of slope. And so just as a recap, because you've already seen this topic, a line that looks like this has a positive slope. A line that looks like this, so from left to right it's going downhill, it has a negative slope. If I have a horizontal line, its slope is equal to 0. And if I have a vertical line, that's not too vertical, that's a little better, its slope is undefined. that should have been in the video in the last section. All right. Hopefully that's helpful. Take care. Bye.